Okay, so anonymization, why is it so hard? Who here has tried to anonymize data before? Anybody? Did you figure out a good way? Do you think you're confident in your choice? All right. We will maybe review today, so we'll see. Why should we worry about anonymization? Why should we care? Any thoughts? Because it's impossible, yeah. The hard problems are good to solve, yeah? Why should we actually worry, though? What worries do we have around privacy? I'll give you just one example. So why should we anonymize? Why should we think about where data is stored? Why should we think about who might have access to where data is stored? Well, we have a very nice friend over the ocean who is one good example of why we might want to think about anonymization. And this is because sometimes we hold data that we don't think is important or that we don't think is sensitive or that we don't think is linkable. But when we actually look at these things, something that is legal today might be illegal tomorrow. And of course, legality and the ideas of who's in control of the data can also change with time. And so even if we have trust right now, it could be that something changes and then we don't have trust. And unfortunately, if we haven't bothered anonymization, then we may or may not be running into the issues that we're running into now. In addition, in general, if you store less data, especially less data at scale, which I know is an unpopular opinion right now, but if you store less data at scale, you become less of also a target for people trying to actually steal that data, access it in a malicious way, or get that data and do something else with it. Because obviously, the more data you have, the more of a target you are, the more valuable that data is for theft. And finally, when we think about the relationships that we would like to propagate when we work with people's sensitive data, we probably want to try to come from a place of trust and understanding. And as we know from this situation, trust is easily broken, unfortunately. So once we break the trust, then it would be very difficult to regain that trust. We have to spend a lot of time. And this is because privacy as a phenomenon, it's much beyond what we'll talk about today. I don't think I have to educate anybody about the history of Europe in this room, about the importance of thinking through privacy as a social, as a cultural, and as a legal construct over time. But I'm happy to debate as we refresh ourselves later if you want to come tell me that privacy shouldn't exist. Okay. So first off, let's try to define anonymization. Any guesses? What is anonymization supposed to mean?
Anonymized data is the data that can be linked to any living person or household.
Do we have a lawyer in the room? GDPR compliant? Yeah, okay. Okay, we're gonna first break down the history. So anonym comes from Greek, meaning no name, right? We can start breaking it further into Latin, unknown origin or authorship, right? This can continue. And then we start getting into actual more legal definitions. And in general, legal definitions, obviously, that we use here in Europe are related to kind of GDPR and other understandings that we had before GDPR. So information that doesn't relate to an identified or identifiable individual, or it can be to the family or group. And then finally, at the end of GDPR, I'll read it out for you. Under GDPR and many other data privacy regulations across the entire world, we have a clause that basically says that information that's been processed such that the data subject is not or no longer identifiable, that this data is now outside of the regulation of GDPR. So why is it also good for us as data people to understand if we do anonymization? Why might that be useful for us in the long run? Who here knows about GDPR? Because to some degree, obviously, I'm not a lawyer, talk to your legal department. To some degree, if we can prove that the data is anonymized to what we think or define as anonymous within our organization, we can also use that data for a longer period of time, because most often the data that we collect under GDPR, we have a certain number of years that we can hold it, and then we must remove it because consent cannot be given for an arbitrary amount of time. So This is how we might define anonymization. Does this teach you technically how to do this? When you read this, do you understand how to implement this? No, it's very hard. Okay, so today we're going to talk about how do we take something very maybe humanly understandable here and translate it into something technical. And to do so, we're going to take what seems to be a pretty simple setup, okay? And then we're going to start breaking it down. And I'm going to call this adaptive privacy-respecting queries with anonymization. Can somebody translate what they think this means? Okay, we'll start breaking down. We have a data source. Maybe it's our data source, maybe it's another data source, but let's say we have a data source and we are over here. We're just an analyst or a data scientist. That's us, because we're PyLady, obviously. Default PyLady, right? And then we want to do some analysis. We want to do some sort of interactive analysis, right? And this analysis must come from this data source. And the problem is we've identified that for whatever reason, under GDPR usage or something like this, we'd like to set this up to anonymously query. And this could be because we have mixed consent. This could be because some of the data we acquired via some sort of acquisition or some other third-party data source, and it means that we don't really have the right to use it. Of course, I'm not a lawyer, talk to your lawyers, but for this reason, we set up this type of situation, and we want adaptive queries. So we want to be able to ask a query not once, but we want to be able to get a response and ask again and again and again. And we're just asking normal data analyst, data science queries. So this seems pretty normal, right? EDA, or something of the sorts. Who here in the room has done some sort of process like this, maybe without anonymization? Okay, good. We have some experts. Okay, and so we're gonna try to build something to do this, and I'm gonna take you through a few ideas. The first idea that we're gonna have is pseudonymization. This is a very popular approach, so we're gonna just talk about it. And with pseudonymization, we're gonna take things like names or personal markers, and we're gonna replace them with some sort of pseudonym. We're gonna just return queries with these replacements, so these things are not gonna be in, or we're gonna be responding with pseudonyms. And if needs be, if we're kind of iffy, we can also redact some columns. What does this mean? You like leave out a column. You just dropped some information. But we're also, because we have adaptive queries, we're gonna allow pseudonyms to be a part of the query. So me as a data analyst, I can get an initial list, and then I can say, oh, I'd actually like to zoom in on these people with these pseudonyms, or people that work for these pseudonyms as their organization, or people that live in this zip code pseudonym, or whatever it is, postal code, state, or something like this. Okay, how well do we think this is gonna work? Pretty confident not working. Okay, so first we'll go through pseudonymization methods because there's many. And the problem with pseudonymization that I find is often we talk about it as if it's all the same, but actually there's very, very different methods that we have, and these methods have very different approaches. So the first one that we have that's kind of traditional is masking. This is probably, if you're doing LLMs, you're probably doing this, right? So anybody that's doing pseudonymization, like we're cleaning the input before we send it to OpenAI API. We promise all of your sensitive data is like this, right? Or this, right? We are definitely sure we caught all of it. There's none that we didn't catch. So that's fine, that's okay. That's industry standard right now. So even Microsoft is doing it that way, so you're not far off. So we apply this mask, and it's gonna replace some or all of the data. So sometimes we'll leave a little bit of an identifier available. Other times we're gonna replace the entire thing with what is sometimes called a token, which is the next one. So we have tokenization. We have table-based tokenization. This means there's basically a one-to-one token match, or we can do some nice fun tricks if we want to somewhat make an algorithm out of it. But basically, we have some sort of match that takes the names and maps them to new names. We can take the city names, map them to new city names. We can take company names, map them to new companies. We can do this with a limited number of categories or a large number of categories. But again, this is table-based, which means this doesn't always scale well, and it doesn't deal with arbitrary data very well. So now we're moving to more advanced pseudonymization. We can do hashing. So probably at some point in time, some of you have used some sort of hash, bcrypt, or other hashing mechanism where you take an input, you either use, you hopefully use a...
Hashing is reversible. So why is it's not pseudonymization? If your hashing is reversible, which they all are, then it's really a pseudonym? Like, the hashing algorithm is known, right?
Yes, well, I mean, you can use salt, and you can also use keys in hashing. So there's ways to protect against like simple rainbow table attacks, as I think what you might be referring to. But most of these methods, we actually want reversibility. So when we're talking about well, this is now I'm partially answering some of the coming questions, but to that point, a lot of times when we're using pseudonymization, we actually do want eventually to reveal the original value, or at least reveal a location similar to the original value.
I've done record linkage with hash values, right? And you can still do it. It works fine because the keys are the same. It's great. Like, you can avoid giving people's names.
Yeah.
But,
yeah, so if you're using this, obviously, like, so we're going to be talking about pseudonymization as an entire approach. We'll get back to some of the security concerns. But also, if you're doing any hashing and you're not using a certified hashing method, so there's numerous ones that are stronger than other ones, and if you're not using salt or some sort of private key to change and rotate every time, then you are opening the door to more linkage attacks and allowing people to potentially link data over a longer period of time, which can reveal more information. And hashing, the one interesting thing about it, so when we think about it from like a deep learning perspective or LLMs, is we actually also destroy the format of the data. So we're destroying the structure, and also hashing, when we use better algorithms, they can get quite large, and this can lead to thrashing on our RAM and other things like this, depending on what high-speed data processing we're doing. And so one that I like to recommend in case you are using pseudonymization at any type of scale, usually hopefully only internally to share data, is a field of encryption called format preserving encryption. And this uses things like stream ciphers, if you're familiar with that, that basically you can think of taking a stream of bytes, replacing it with another stream of bytes, and you can do this in such a way that you have format preservation. So there is an open source library that I contributed to that does this, and there's probably many others that do this. But this is potentially one way, as long as you rotate your keys appropriately, that you can have semi-linkability and then choose when to rotate keys and break the links. And the other nice thing, if you're doing deep learning or other types of representation-based learning, is you have something that at least looks kind of like what you're expecting the data to look like. So here's just some of the pseudonymization. And now we're going to try to work, and we're going to work together because we're supposed to be social and have fun. And I'm going to give you 3 minutes to discuss 3 questions with your neighbor. First question, and we'll revisit these questions so you get some practice. Does pseudonymization provide a way to find group trends so we can analyze things in groups without revealing too much about any one person? And I'm going to let you define what is too much. We're going to think about this. Second question, does pseudonymization prevent queries that can reveal one individual? So can I zoom down to a one-row answer or one-person answer? Because a person might represent more than one row. And finally, third question, does pseudonymization allow this adaptive query setup? So can you think of a way, and I want you to be a little bit data scientist today and a little bit evil hacker, evil privacy hacker. And I want you to think of, we already got some in the room, so we want you to think of, can I do a second query or a third query that reveals something more about any one individual? can I devise this adaptive type of attack that lets me single in on one person and learn a bunch of things about them? Does that make sense? Okay, you have 3 minutes, make friends with your neighbor, try to talk to somebody that you don't work with, somebody that might be new, and then I'll break you up after 3 minutes. If you're online, please use the chat and chat with each other at least. Okay. What do we think? What's the first one? Who says yay? Who says nay? I was nicer than you all. I wanted to give pseudonymization 1 check mark. This is the 1 check mark that pseudonymization gets. And I think I wanted to say this first one is, if you do pseudonymization really, really well, and if you have a fairly static query situation, and again, I know we said adaptive queries, but technically this first one's about a static query. So if you do very, very well pseudonymization and you redact a bunch of stuff and you choose large enough groupings and you remove some data, I do think you can potentially argue this first one is true. But I'm with you in that it's a very weak guarantee, and making sure that you do it right is pretty hard. It's pretty easy to do it wrong. All right, what do we think about the second one? Why? Why?
Because if there are like multiple information about let's say each person, and then maybe each individual information on its own cannot tell you the identity, but maybe a combination of them can tell you the identity.
Perfect. And also technically I didn't say anything about query aggregation. So technically I said you could still use the pseudonym, and you could say, you could notice, oh, there's only one person in this age group. I'm going to just query that age group and learn everything about them, right? So there's really fun attacks that we can use that we'll talk about also in the next section. And does it allow adaptive queries that give this first promise? Can I do multiple queries in a row and still guarantee only groups are learned, no individuals are learned? No, definitely not, right? So like the more adaptive, you're gonna notice that this adaptive thing is actually probably one of the hardest parts about this problem. So in an adaptive situation, this falls apart immediately because again, I could use these kind of grouping overlaps to reveal more and more about a person. Okay, so the next idea that we have is we're gonna throw away pseudonymization. I think pseudonymization is still really useful, I wanna say, but it's not a good usage for anonymization. So if we're still focused on anonymization, we're gonna try aggregation and redaction. So in this situation, we're only gonna allow aggregate queries. So you can't actually query one person. We're gonna redact sensitive columns that don't need to be used for the query. So we're gonna drop all of the columns that we don't have to use to answer. And we're gonna repress query groups that are under some minimum. And here we could put it 5 persons, but really we could scale it depending on our data set size. So if our data set size is like 1 million persons, we could set a threshold of 10,000 if we wanted, right? So it's gonna depend on our data set size. And for our discussion, I'm not gonna necessarily say what the data set size is. I want you to kind of think about all potential data set sizes. And this might look familiar if you've ever implemented or thought about something like k-anonymization. So if you used k-anonymization, this is what you're using. So we're gonna think about that. What is our feeling so far? How are we feeling about this aggregation? If you want to make a photo so you know the rules, do it now. Or I'll switch back when we're debating the questions. Any questions about the rules? The approach? Yeah.
How do we in practice only allow aggregate queries? If someone gets the data set, how do we prevent him from seeing the data?
So basically what you'll do is you have to put a query interface between the actual data and the user, right? And you essentially are the API in between that. And that is where you actually implement the privacy control. So there, which means also we won't be talking about scaling today, but the scaling is an important problem here, right? Because if we have one analyst and then we have 10 analysts and then we have 100 analysts, we have to scale this very differently. And depending on how we shape this problem, this can become a almost computationally infeasible problem at scale. But we won't get into that today. If you want to talk about that as we refresh, then please let me know. Okay, but first we're going to try to do this aggregation and redaction. So again, we're trying to do a good job. We're trying to only return 5 people or more, or 10 people or more. We're only answering aggregate queries. We're redacting other information. Maybe it works. Okay, you already know the questions, so I will give you now 3 minutes. What do we think? What do we think the first question? So we're going to call this aggregation and suppression, because a lot of times this is talked about query suppression. We suppress queries that we cannot answer because it would reveal too much. So does it provide a way to find group trends without revealing too much about any one person? Yes. Okay. Does it prevent queries that can reveal one individual? Yeah, it's in the definition, literally, right? What about the last question, though? Has anybody put an evil hacker on and figure out why the last question?
Sorry, can I ask
Yeah,
something?
yes.
I have something to add about prevent queries that can reveal one individual. If we are talking about, like, if the different aggregations, I think, can have a different impact here. So let's say if I'm looking for a person and I know that his surname is Smith, and I'm aggregating my data based on the people that are surname Smith.
Ah, okay.
And then I have 5 people with different salaries, let's say. And then I know that this guy is someone, let's say, rich, and I'm trying to find him. And then out of these 5 Smiths, if I see the person who has the highest salary, then maybe that's the guy that I'm looking for.
Yeah, so if you're allowed to say the max of a group, you can immediately reveal the salary of an individual. This could be true. But again, we have to do aggregate queries. So because I know that max and min have an immediate privacy reveal, I could say I only allow average.
Okay, so we will have some kind of a rule.
You versus me, red team, blue team. No. Go.
This minimum number of this query suppression, is it known to the analyst or not? Because I think if you told them what the query suppression limit is, you could do a lot of queries and find that information that they shouldn't know. So it should be unknown to the query.
Okay, so now we're getting into the fun attacks, or the more fun attacks. So if you like thinking like a hacker, privacy is a fun space for you to work in. You are thinking exactly along the lines of these adaptive queries, these adaptive attacks. We can do singling out. And we can actually single out even if we shuffle. And there are also ways that we can run probabilistic or even logic solving attacks. So there's some cool notebooks in my book repo. It's on GitHub. So if you want to play out evil hacker, there's some ways to do this. But we're going to think just about one. I want to find the salary of the highest earning woman in a data set. What's the first query I run? What about, we'll start with all salaries. We could do all women. We're going to start with all salaries. What's the next query I'm going to run?
All salaries under some, or above.
By the way, yeah, so how should I group this to reveal the highest earning woman? No, okay, all salaries, but I get to choose a grouping. What's my grouping? I could do age. Do we think maybe the highest earning woman is probably one of the older women in the company? I could do by department, right? So I'll take all salaries and I want to group it some which way. In this, I hopefully use information that I have about the organization, or I make some guesses. I could do multiple queries, so I could make guesses, right? I want to choose a grouping here, and I want to eventually kind of see that one of these higher, probably this isn't how the salaries look, right? But I want to kind of start to see where the higher salaries are a smaller number of persons. Then I'm going to subtract my next query. What's my next query? All salaries minus what? Yes, exactly. So if I run these two and I've aggregated my groups in such a way, I might literally have a reveal here of -1 on this query, right? So here the woman is included because all salaries. Here she is not included. We never returned her, but we returned all the information around her. And I was able to use a little bit of thinking to immediately reveal. And this is the big problem that we have with aggregation, is we're revealing a bunch of information in between what we're suppressing. So when we suppress information, we immediately reveal information. This is the trick. So if there's this attack, there's many, many other attacks on these types of aggregation methods. So if you want to dive in further, A, we can talk about it further, and B, you can play around with some Jupyter notebooks if you want to try it out yourself. So we're going to move to the third idea. And who here has heard about differential privacy? Who here has used differential privacy? Who here has implemented differential privacy? Okay, just to make sure. But we have another friend here, right? Okay, so the interesting thing about differential privacy, which was invented by a group of people thinking about this problem who have a mixed background between cryptography and machine learning. So they're math people, like this group, and they're statistics and probabilistic thinkers. And you can see that in the way that differential privacy is defined. Because instead of thinking about the properties of the data, because we see how hard this is to try to design data in such a way that we do it cleverly, we move away from thinking about the properties of the data set itself, and we move into properties of the query. We want to move into properties of the processing instead of properties of the data. And there, we use uncertainty and error to provide individual protection. What do I mean by this? If I learn something about you and the process uses differential privacy, there's always some amount of uncertainty and error because of the way the differential privacy works that I can never be fully sure whether you are in the result or not. So this uncertainty that we're adding is similar to uncertainties that we see in cryptography, where we can never be fully sure what's the process that was used, and so we're never 100% certain of how to, let's say, break an encryption method. Finally, we're going to measure what can be learned rather than these type of ad hoc continuing to tape on new types of protections. And we're going to do this in a way that is mathematically sound. And we'll get into that in a second. I want to show you an idea of differential privacy. So this very high-level idea. We're going to say that here you work at a company. They have a BI dashboard that has payroll by role. You find out that somebody new is joining your team. You know what role they're going to be. And let's say this is like max payroll per month or whatever. It's the accumulation of payroll per month, something like this. You make a screenshot, and then you find out you need to ask for a raise. And you go ask for a raise, right? No? Yeah. Because you can use the screenshot, and you can see how the payroll by role changed the week or the month after they joined. And you can use this as long as there's not too many people joining the company in one role at once. Or you can do some clever math and decide, well, there's a high probability that they're more than half of this change or something like this, right? So use your external information, and then you can make an inference. And this is exactly the problem that we're trying to solve with differential privacy, is the fact that anytime we're showing information, we are leaking information about any one person or groups of persons. And so we have to start thinking, how can we show information but increase uncertainty? And now we'll get a little bit into the theory of differential privacy. Again, we're going to stay at a pretty high level, but I'm happy to talk much deeper about this. The first definition, we'll just go with the first definition. There are many definitions of differential privacy. The first definition says we have a database. We have an initial database. We'll call it D1. Then we're going to add or remove one person. And then we get a changed database or a different database that is now called D2. So D2 and D1 are only different by one person, okay? And when we're querying, so when we're the evil hacker, we're going to be querying, and we got to try to decide, are we querying database 1 or are we querying database 2? And we're going to be able to use as many queries as we want or shape our queries differently, and we're still going to just be guessing, is it database 1 or database 2? Because that will tell us something about this individual. And if I can't learn much about whether it's database 1 or database 2, if I get it wrong often, it means that I will also get wrong exactly what this individual contributed. And that gives us this property of privacy for every individual. And if we can guarantee privacy for every individual, we can also get close to what we mean by anonymization. And for those of you who would rather read probably my poorly font choice and location probabilities, I like to show this one because it basically shows the left-hand side is the information that we get from the response. So essentially the update of our information based on the response. And the right-hand side is our original assumption. So it's not quite Bayesian, but it's Bayesian-like. And we want to bound these. We're essentially bounding the amount of information I can learn in the response by a small parameter, e to the epsilon. And we're not going to get much into parameters today, but this epsilon choice can help us make actual bounded guarantees. And so this is from Damien Desfontaines. He helped implement differential privacy at Google, and he's a great person to chat with about these topics, and now runs his own independent consultancy on these topics. But he also contributed to a really cool open source library that I also have a Jupyter notebook on called Tumult Labs. And this is a nice graphic from, he has a longer series if you want to read a longer series on differential privacy. But these are the both theoretical and computational lower bounds depending on our epsilon choice. So here, we're in the middle, our epsilon choice shows that we have an initial suspicion of, let's say, 50-50 whether a person is in. And that means the most we can update is maybe to a suspicion of 0.6, and the least we would update is 0.4, right? So we would lose information because we become more uncertain after seeing the next response. And you can see here that obviously when we get to very high epsilon values, when we're dealing with an adaptive query situation, we can almost reveal completely the information. And this is because that epsilon, again, controls this bounds and therefore controls the amount of information we're releasing per response versus the amount of uncertainty or noise or error that we're putting into our response.
How do you guarantee, if you're using laws from GDPR, how do you tailor this to meet some standard or threshold?
Yeah, so there's some recommendations from the ICO, and there's also recommendations from Infra, so like the French authorities and technical group on epsilon choices. But I think some of the best work that I've seen is Damien has a blog of real-world differential privacy deployments that have posted publicly their epsilon values. And so I think that's a really solid start. And again, the nice thing that Damien's become a good friend. Anyways, the nice thing that Damien always reminds people when they're learning differential privacy is better to start with differential privacy even with a high epsilon, because you can always make the epsilon lower over time. But as you just saw with the aggregation, we can never add more privacy into an aggregation setup. So even if you're using differential privacy, and let's say you're starting with epsilon, and we can debate also in deep learning, we use much, much higher epsilons because we also have the regularization and the mini batching and other things that allow us to add, again, some obscurity to the processing. And because of this, we tend to use epsilons like even 8, 9, 10 in deep learning because we have some other ways of reasoning about the query release, We are releasing essentially the query as a gradient update. We're not releasing the query as a raw value that somebody can use. Although we can debate a lot. I have a whole series on the memorization problem in over-parameterized models, which we can also debate about, which means if you have a very, very large-scale deep learning model, the chance that it has memorized part of the training data is quite large, and we can debate that at a different time. I also have a talk from last year's PyData Berlin on that, if you want to look it up. But essentially for differential privacy, what I want you to think about is here we're reasoning again about information release. And we're able to start to add this noise to control the certainty of the person getting the information at the other end of the query. And so this is a final debate. I want you to think about this. I know differential privacy can be difficult at first to get your head around. I hope I've given you a bit of a flavor for it. I want you to think about these ones. You're going to have 2-3 minutes to debate with your neighbor, and then we'll come back and I'll wrap it up for us. Okay. Sorry, I know we want to have snacks together and things. And I just want to give you an idea. Differential privacy is a field that you can learn about and study your whole career, and there will still be new things that you learn. I have a book. It tells you about differential privacy and other stuff, which I'll tell you about in a second. But if you want to also discuss more deeply about differential privacy tonight, please just find me. We can sit, we can sketch out your problem, free privacy advice for the next few hours. So, does differential privacy provide a way to find group trends without revealing too much about any one person? Yes or no? What do we think? Yes. Yeah, is literally in the definition. Does it prevent queries that can reveal, here I should say, too much about any one individual? To some extent, yes. We could also say no here, but then you're also always uncertain what information you learned. So in the end, it kind of depends how you call information. And then does it allow adaptive queries that uphold the privacy promise? Sorry, I did it too soon. Yes or no? Okay, I revealed I differentially privacy to myself, not. And yes, and this is gonna obviously depend on the situation, so we can also attack differential privacy over time. And if differential privacy is poorly implemented, it also leaks information in the way that the noise is chosen and other things like this. So it's important to also understand attacks on differential privacy systems and to always use audited libraries and tools where people have actually thought through the problem. So just like you wouldn't roll your own crypto, probably not, unless we have cryptographers in the room, which is also totally fine. Love hanging out with cryptographers. Don't roll your own differential privacy either, okay? There's plenty of really cool open libraries. And what I want to get to, and hopefully you're starting to think about, is when we actually study privacy at a deep level, we're actually studying information theory. Why?
Because when you're getting more privacy, you lose information.
Exactly. And the other way around. The more information I can learn from something, and this is exactly why we have the deep learning privacy problem, so the more information I can extract and symbolize in something and store, the lower the privacy guarantees that I have. And so this isn't this isn't meant to be extremely linear, but I want you to start to think of privacy not as on-off, but as a range, as kind of a series of choices that you might make between completely erasing data, which would not be very useful. None of us would have jobs at PyData if we erased all data. Although we could do just big reset and restart again, okay. Anyways, we have that, and then we have all the way like raw, complete, fully transparent data shared across many, many megacorps, and then we have no privacy, right? So I want you to start thinking when you're working with sensitive data about reasoning, where is the amount of information that I need to do my job, but the highest amount of privacy I can guarantee or gift to the persons. So anonymization is hard because it's really difficult to actually learn something and to guarantee that you're not gonna reveal something about one person. Studying privacy is, I think, really cool. Obviously, I'm extremely biased, but it's going to teach you things like information theory, learning theory. I've learned a lot about cryptography, other fun things like this. So if you're new to this field and you feel like you might want to specialize, I'm also here to give career advice very happily. Some people automatically have more privacy risk. So I was able to find that high-earning woman because she sticks out. And when we think about privacy risk in our data sets, it's often people that are marginalized, people that are in smaller, easier to reveal groups. And this is why I think it's such an important thing for us to think about, because when we think about data ethics, we are also thinking about how much we're learning from who, and who has control over what we're learning and who doesn't have control about what we're learning. So we could accidentally, arbitrarily violate somebody's privacy just because we don't realize they're an outlier or they're in a smaller, more easily targeted group. And finally, as you've hopefully learned today, and as you maybe want to practice, if you shape your use cases, you can maybe decide, you know what, this time actually pseudonymization is okay. Or this time actually aggregation is okay. Or this time, you know what, we're actually going to try out differential privacy for the first time. So actually shaping out and building your use case and thinking through the threat model is a regular exercise that you can do to help evaluate the options and to make sure that you can offer the best privacy for the amount of information that you need for doing your job, right? I'm not here to try to tell anybody not to do your job. If you want to learn more, I have a book, I have a newsletter. You can reach out to me anytime and say hi. And my dad and my stepmom are here. They're the ones that introduced me to computers and computer science. My stepmom's got a bunch of patents. My dad was an electrical engineer working on routers. They were both at research labs. So if you want the OG me, then go talk to them during the break. So thank you very much, everybody.